All right, it's time to finally learn what a differential equation actually is. Right, so just to have some analogy, let me tell you what is not a differential equation. So an algebraic equation is not a differential equation, or a functional equation is not a differential equation either. Right, so an ordinary differential equation, so it is an equation that relates an unknown function and its consecutive derivatives of just one variable t. So here are a few examples, right? So here the unknown function is v of t, and the equation relates its first derivative to the function itself, right? So here the unknown function is f of x, the independent variable is x, and here is the equation, right? So the next one is an equation that relates the first derivative and the second derivative and the unknown function and the independent variable, right? So in other words, so the only things that are allowed in an ordinary differential equations are the independent variable, the unknown function, its first derivative, its second derivative, and so on. Just a little convention. So for your convenience, I chose to, I don't know why, but in the textbook, the independent variable is usually denoted t, and the dependent variable is y. So the unknown function is y of t, and I will stick to that notation. So whenever we do any exercises or in my lecture, so remember that t always means the independent variable and y of t is the unknown function. Let me maybe emphasize the fact that there is just one variable. This is important, so that there is only one independent variable. Right? So further, solution of an ordinary differential equation is well, something that you just substitute as the unknown function, and then you get a true correct equality. Right? So here is an example. So the point being is that it is very easy to verify that something is a solution of a given differential equation. Right? So you just let y be this formula, and then you compute the left-hand side and then the right-hand side and see that they are equal. Then the solution as a noun is that. So, but now to solve as a verb and differential equation means to find all of its solutions. Right? So if the question is to solve this ODE, then you can try to see that these are, each of these equations is each of these formulas is a solution, but and you can of course assume that all solutions are given by this formula, and it is in fact true, but at the time being we cannot really prove that we have actually found all possible solutions. So my point now is that every differential equation always has infinitely many solutions, so that's just natural. So it's just like an equation of usual algebraic equation of degree 3 has 2 solutions, degree, I don't know, 27 has 27 solutions. So in the same way, a differential equation always has infinitely many solutions. So the order of an ODE is just the highest order of the derivatives involved, right? So if the highest derivative is the first derivative, it's a first order ODE. Second derivative, second order ODE, and so on, right? So this is an ODE of order 2017. So notice that this notation here, y and like a superscript in brackets 2017 means that this is y prime, 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 and so on, 2017 times prime. Right. So usually an ODE is either explicitly written or can be easily written, so that the left-hand side is just the highest derivative involved, like this. Or, so notice that if you say look at, I don't know, at this differential equation, it is a second-order differential equation, but it's not really a big challenge to just take this and move everything to the right-hand side. So then the left-hand side will be just, so let me write it, y double prime equals 1/3 y prime plus 1/2 y. Minus, sorry, that's minus. Right? So these are sort of good differential equations. So a bad differential equation is something that cannot explicitly be solved for the highest order derivative, and the theory of ODE just doesn't concern these. I've never heard of any consistent theory of differential equations that are not explicitly written in the good form when the left-hand side is the highest derivative. So that's just sad but true. Well, anyway, it's not a big deal, because remember that differential equations mostly are used for modeling, and in all possible real-life scenarios, the highest order derivative of the unknown function is explicitly expressed in terms of the lower order derivatives and the function itself. I only know probably one exception of that rule. So the rest of practical questions, I usually produce good ODE straight away.